So, welcome to today's class. This, I think, is lecture number 8 in ray optics. And if I remember correctly, we had started lenses, two types of lenses. We had seen, we know two types of lenses are there. The first type of lens is known as a convex lens, and the second type of lens is known as a concave lens. I hope you all remember this. Convex lens are converging lenses. We all know this, yes or no?
Yes, sir.
Great. Everyone is looking in good spirits today. All thanks to breakfast. Concave lenses are known as diverging lenses. We also discussed that we have two types of focus or foci for lenses, and therefore two types of focal length. One is known as the first principal focal length, the other one is known as the second principal focal length. Now whenever we talk about lenses in general, which focal length are we talking about, first or second?
Second.
Well done. And second focal length of convex lens is always positive. We have seen that. And second focal length of concave is always negative. We have seen that. The last thing I think I discussed, oh sorry, we discussed in the class was formation of image by a convex or a concave lens. And I asked you to see those diagrams. Have you seen those diagrams in the sheet?
Yes, sir.
Okay, that means we will have to spend very less time and we will go through those diagrams quickly. When I say quickly, we will start with image formation by a convex lens first. Obviously, converging lenses will always come first. We did converging mirror first. Converging mirror was concave mirror. So we did concave mirror first, then we did convex mirror. So in here in this case, we will do image formation by convergent lenses, that is convex lenses. And here it comes on your screen now. Again, if you remember, in case of mirrors, we had started from infinity, then we came close beyond C, then we came at C, then we came between C and F, and then we put our object on focus, and then we move to a point between focus and the pole of the mirror. Exactly similarly, we will be doing it for both the lenses, convex and concave. So the first case is the object is definitely placed where? The object is definitely placed at infinity. You can see these parallel lines coming from infinity. They are not parallel to principal axis. If these lines, remember, note it down. If these lines were parallel to principal axis, the image would be formed exactly at the focus, right here. But if they are not parallel to principal axis, the image is somewhat enlarged. It is still formed at the focus, but you see some length or some height of that image. It is not a point image. That is the difference between light which is parallel to the principal axis and light which is not parallel to the principal axis. Light which is parallel to the principal axis will always give you a point image. A light which is not parallel to principal axis will not give you a point image, but in both cases image will be formed at the focus. Image is formed at focus. It is real, it is inverted, it is very small, magnification is very less compared to -1. If this were parallel lines, parallel rays to principal axis, the image would have been a point image. Do we understand this?
Yes, sir.
What you got to do is you got to draw this diagram, understand this diagram, and you will have to note everything that I have ticked. Where is the image form? For where is the object? I'll give you a minute to note it, do it. Then that takes us to the second position. Now remember, in case of mirror, it was called C, the center of curvature. Remember, there are two centers of curvature here. So instead of calling it center of curvature, we are calling it 2 times F, 2 times F. So now the object is not at infinity. It has come closer and it is somewhere between infinity and 2F. So the object is placed here. Can anyone see this? This object has a height. The
Yes,
height of
sir.
the height of the object is h. It is placed beyond f. So sometimes we may call it beyond f, or we may call it between infinity and 2f. Now, what do you see here? The image is formed, which is real. As you can see, the image is real. It is inverted. One more thing to note here, and if you can remember this, image is formed between f and 2f. You can see it here. Do we see it here? This is my f and this is my 2f. Why they are two focal lengths? One is the first principal focal length. The other one is the second principal focal length. First one is first principal focus. The second one is the second principal focus. Can you tell me which one is which? You're looking at the lens, you're looking at two foci. Can you tell me which focus is which? If I call this, which focus is this? Is it the first principal focus or is it the second principal focus?
First.
Yes, well done. You must remember this. This is my F1 and this gentleman is my F2. Don't forget it. I hope you remember it. Okay, let's move ahead. The image is diminished. It is small in size, but it is not very small. When the object was at infinity, it was very small. Now it is small, but not so small. The magnification is less than 1. One thing you have to note here is while we are coming from infinity towards the lens, the image is getting bigger. The image is getting bigger. Do we understand this?
Yes, sir.
The same thing was happening in a concave lens, a concave mirror. When the object was at infinity, image was its focus and it was very small. When the object was coming towards the mirror, the image was getting bigger and bigger. Do we understand this? Do we remember this?
Yes, sir.
Same thing is going to happen here in convex lens, and we will see it happening. Right now, we are on case number 2. In case number 2, object is placed beyond 2f or it is placed between infinity and 2f. The image is formed between f and 2f on the other side. The image is real. The image is inverted. Image is small. That is what you need to note. You need to note the diagram. You need to note all the particulars that I have ticked, and you will get a single minute to do this stuff. Well, great. That takes us to the next position. From infinity, we have come to infinity and 2f. The next position is 2f, which is same as the center of curvature for the concave mirror. The object is placed here. As you can see, it has got some height. It is placed as 2f. No points for guessing where the image is. The image is real. The image is inverted and it is exactly at 2f. Object is placed at 2f on the left hand side, which is 2 times the focal length of the first principal focus. The image is formed at 2f on the other side. The image is at the same distance, therefore it is of the same size and magnification is -1. Again, you see the same thing. As we are moving from infinity towards the lens, the image is getting bigger. Do you see the resemblance? Do you see the common feature between this concave mirror, which we have done before, and the convex lens images following the same concept? Yes or no?
Yes, sir.
Again, you'll have to draw the diagram, note down the things that I have marked in your sheet, and I'll give you a minute for the same thing. We are done The case where object is placed as 2F, remember the object is moving closer, so the next position is between 2F and F. You can see the object is placed somewhere here between F and 2F. What do you see? You see an inverted image. You see a real image which is always inverted. Remember, as the object is moving closer, the image is moving away. Do we see this?
Yes, sir.
As the object is moving closer, the image is moving away. Now the image is formed beyond 2F. The image is formed beyond 2F. It is after 2F. The image is enlarged. The magnification is greater than, it should be -1, because +1 means that it is on a virtual image. This is not a virtual image. This is a real image. The image is bigger than the object. It is formed beyond 2F and it is real and inverted. You'll have to note it down. I'll give you a minute. Good that you have done this. Now we come to the next case, which is case number 5. What would be case number 5?
Between F and O.
No, that is why you are following the sheet and you are not following your brain. Case number 5 would be object is placed at the focus F. So the object would be placed here. This case is missing from the sheet. So you'll have to understand it as well. When the object is placed at the focus here, what about image? Will it be real or inverted? Will it be real or virtual? It would be real. Will it be inverted or will it be erect? It would be inverted. Is everyone following me? Can I have some raise hand that we are following me? Only one student is following me. That is not good. What about the others? You are still in the class?
Yes, sir.
Okay. It is inverted. Where it is formed? It is formed at infinity. It is enlarged, very enlarged. In fact, magnification is very, very, very high. So we will see a very large image even for a very small object. The diagram is not there. That diagram we have already drawn when we had seen the definition of first principle focus. Do you remember that diagram where we had drawn object at the focus and image was formed at infinity? That is the same diagram that you have to draw here. I will not draw it. Two reasons. First reason is I don't have space. The second reason is I want you to draw it on your own, which is the major reason. I can obviously create space. I'll give you a minute to draw this diagram. Case number 5, object is placed at the focus. And now we come to the last case. And the last case is case number 6. And case number 6, I would have to correct the number here. Case number 6 would be object is placed between F and O. The diagram here. You can see the object here. O is here. Object is here. It is placed between F, the focus, and the optical center. And remember one very important thing, the image is virtual and it is on the same size, same side of the lens. You can see this image is on the same side. It is erected. It is enlarged. The magnification is greater than +1. Same case as what we saw in case of a concave mirror. Only in one case, only in one case, only in one case, concave mirror was forming virtual image. That virtual image was always enlarged. What was that case? For a
Yes,
concave mirror, the object was placed between F and O. Here also same thing. So if you understand concave mirror, you have understood convex lens and vice versa. For same positions, we are getting the same position of the image as well. Not the same position, but wherever they are formed, same type of image, same type of magnification. Concave mirror was converging mirror. Convex lens is converging lens similar to each other. Do we understand this?
Yes, sir.
I'll give you a minute to note it down. And now I take you to this small table that is also given in your sheet. For all the corresponding position of the object, we have the corresponding position of the image. Can you see this? For the object, we have the position of the image. We also have what type of magnification is there. I'll give you a minute. We have already seen that. For object at infinity, image is formed at the focus. Between infinity and 2f, images between f and 2f. At 2f, images at 2f. Between f and 2f, as you can see here, the condition has reversed. In place of an object, we have the image, and here also you can see the condition of the image has been changed by the condition of the object. If you understand one, you will be able to understand the rest of them. When the object is at the focus, image is at infinity, this has been replaced by this one. Everything has a mirror over there. When the object is between f and o, this is the only case which does not have a replica. The image is in front of the lens. Magnification is greater than 1. This one table conceptualizes everything about convex lens. You can remember this. Well done. I'll give you a minute to note it down. Then we move ahead and see one more important point. We have seen the same point in concave mirror. We will see the same point here in the convex lens. A convex lens, what it can do, what it cannot do. A convex lens or a converging lens, what it can do or what it cannot do. For a real object, it can form what type of image? It can form a real image as well as a virtual image. Do we understand this?
Yes, sir.
For a real object, it can form real image as well as virtual image. If the image is real, magnification can be less than -1. It can be equal to -1. It can be greater than -1 as well. Do we understand this?
Yes, sir.
But if the image is virtual, the magnification is always greater than 1. You can see it here in the table. Can I have some raised hands from everyone that we understand this? A convex lens can form real as well as virtual image of a real object. Let us now move on to a virtual object. And I would be very pleased if you can tell me what it can do for a virtual object. We have not seen the case in the diagram, but it is for your understanding for a question. If the object is virtual, what type of image can a convex lens, which is a converging lens, form?
Real image.
It can only form a real image. That is absolutely correct. For a virtual object, it can only form a real image. It cannot do one thing. It cannot do one thing. What is that thing that it cannot do? It cannot do one thing. What is the one thing that it cannot do? It cannot form
Virtual image.
of what?
Convex lens.
Convex lens cannot form. For a virtual object,
Virtual image.
for a virtual object, it cannot form virtual image. So, does it remind you of something that we have done before? This was exactly the same case for a concave mirror. Concave mirror cannot form virtual image of a virtual object. Similarly, here, convex lens cannot form virtual image of a virtual object. Do we understand this?
Yes, sir.
I'll give you a minute to note it down. Well, then we move on to this column, this table, real image and virtual image. We always know their differences. This is just to go through them. Real image for a convex lens, for a lens we are talking about. Real image is on the other side of the object. Remember, for a concave mirror, it was on the same side. That is the difference between the two. It is towards the object, it is on the same side. Real image is inverted. This is erect. Magnification is negative. Oops. Why this is on here? Magnification is negative. Magnification is positive. U is negative. V is positive. Here U is negative and V is also negative. For a convex lens, the real image can be smaller, same size or bigger than the object, but the virtual image is always magnified. Do we understand this? Yes sir, no sir, tell me sir.
Yes, sir.
Well done sir. I'll give you a minute sir to note it down sir. Well then, we move ahead. We are done with the converging lenses. Now it's my duty to move on to the next type of lens. And the next type of lens is a divergent lens or a diverging lens, concave lens. Again, here we only have two positions. Here we only have two positions. Position number one is when the object is placed at infinity, real object placed at infinity. What happens? Image is formed at F. You can see that image is formed at F. It is virtual, it is erected, it is highly diminished. If the rays are coming parallel to the principal axis, image will be a point image. If it is not parallel to the principal axis, image will be very, very small, but not a point. This is the diagram. This is the convergent lens. This is the divergent lens. Please draw the diagram. I hope you understand this. It is pretty simple. This concave lens, image formation by this concave lens is same as image formed by what? It is same as the
Concave
image.
lens.
Array! It is same as the image formed by a convex mirror. Do we understand this? Concave mirror is similar to convex lens. Both are convergent apparatus. Concave lens is same as convex mirror. Do we understand this?
Yes, sir.
Yes, sir. Please note down the diagram, sir, and write where the image is formed. Well, then we will move forward and we'll move forward to the only other position possible, and the only other position possible is when the object is placed not at infinity but anywhere else in front of the lens. So when the object is placed anywhere else in front of the lens, the image is formed between F and the optical center. You can see the image being formed here. It is erect. It is always diminished for a concave lens. As in the case of a convex mirror, we only have two positions. Position number one, infinity. Position number two, anywhere else but infinity. In both the cases, image is virtual and it is highly diminished. I'll give you a minute to note it down. Well then, comes a question. And you already know the answers for this question. What can a concave lens do and what it cannot do? For a real object, it can only form
Real image.
we are talking about concave lens, beta. We have seen just now what it does to real object. It always forms,
Virtual image.
please don't forget it, For a real object, it always forms a virtual image. If I change it to virtual object, for virtual object, it can form real images as well as virtual images. There is one thing that it cannot do. What it cannot do? A concave lens cannot form a concave lens cannot make what? It cannot make real image for a real object. Do we understand this? It is similar to a convex mirror. A convex mirror cannot form real image for a real object. Similarly, a concave lens cannot form real image for a real object. A convex lens cannot form virtual image of a virtual object. Concave mirror cannot form virtual image of a virtual object. Both are same. Similarly, convex mirror and concave lenses are same. Do we understand this?
Yes, sir.
Please note it down so that we can move ahead. Well then, we move on to this again. Same thing being repeated here again, but I've seen same question coming many times in the exam, and that is why we need to just see it. If the object is real, if the object is real, image is formed by one lens and it is virtual. Object is real, image is virtual. Then we can identify if the object is real and the image is virtual, then we can identify whether it's a convex lens or a concave lens. If the image is enlarged, then it is convex lens. If the image is diminished, then it is concave lens. This is the diagram given for both the lenses to how to identify convex lens and convex and concave lens for a real object. If the image is virtual, if the image is enlarged, it is convex lens. If the image is diminished, it is concave lens. Do we understand this?
Yes, sir.
Please note it down so that we can move further ahead. Okay then, up till now what we have seen is the image formation by a convex as well as a concave lens. Now we shall move on to something known as the lens maker's formula. Now, before going on to the lens maker's formula, we must understand that we've already done refraction at a concave or a convex surface. We have seen that the refraction happens once. In case of a lens, we have two curved surfaces or one curved and one plane. Whatever the case be, wherever there is a lens, the refraction through a lens happens twice. Do we understand this? Because there are two refracting surfaces. So refraction through a lens happens two times. And if we have to analyze both these separately, you will have to first draw this diagram, which I am going to show you. This is there in your sheet, page number 25. I'm showing you the enlarged view of this diagram. I hope it comes on your screen now and you can see it in totality. Do you see this diagram, bacha?
Yes, sir.
Now, just to understand what is happening here, let us first understand the terms. What is u? What is this mu m? This mu m is the refractive index of the medium where this lens is placed. Do we understand this? Can I have raised hands? Mu m is the refractive index of the medium where this lens is kept. It may be kept in air, then mu m becomes 1. It can be kept in water, there mu m becomes 4 by 3. Now, can you tell me what does this stand for? Mu L, what does this stand for?
Refractive index of lens.
Refractive index of the material of the lens. That is correct, my dear kids. Mu L stands for the refractive index of the lens. This you can see as C1. What does C1 stand for? Now, to understand C1, we must understand that object is placed here. Do you see that the object is placed here?
Yes, sir.
Then this surface is the surface where refraction happens first. So this is called surface number 1. Do we understand this?
Yes, sir.
Then this is the surface where refraction happens. The second refraction happens. Do you see the second refraction? It is happening at point B. Do you see this, everyone?
Yes, sir.
The first refraction is happening at point A, which is surface number 1. The second refraction is happening at point B, which is surface number 2. Now we come to this C1. What is this C1 now? What is this C1 now, bacha? Understand the terms and it becomes easier for you to solve any question. What is this C1? The C1 is the center of curvature for the first surface. Do we understand this?
Yes, sir.
C1 is the center of curvature for the first lens, and there is a small thing that is written. This is R1. What do you mean by R1? 1 and 2 are interchanged here. What do you mean by R1? Anyone?
Radius of curvature.
Of what? Of the
Of.
first surface. Do we understand this?
Yes, sir.
Then we have C2, which is the center of curvature for the second surface. Do we understand this?
Yes, sir.
Then here we have R2, which is the radius of curvature for the second surface. Is it clear to everyone?
Yes, sir.
Then we have U, which is the distance of the object from the optical center. This point is the optical center O. Then we have V1. This V1 is the image formed by the first surface, which is written as I1. Do we see this, everyone?
Yes, sir.
So this object is placed at point O. O is the object. Through the first surface, image is formed. This image is I1. Can I have raised hands from everyone that we understand it? Great. We are moving with great speed. Now, this image I1 will act as an object to my surface number 2.
2.
I1 will act as object for surface number 2. Do we understand this?
Yes, sir.
Well done, my dear friends. Then I have the final image I, and the distance of this final image from the optical center is V. Do we all understand the meaning of all the letters and words and alphabets written there?
Yes, sir.
I'll give you a minute to draw this diagram because this is a very important diagram for you to understand what is happening in case of refraction by a lens, because after that I will make the diagram smaller and move on to the equations which you have to remember. I'll give you a minute. I'll give you a minute to note this diagram. Do not mark it in the sheet. It is very small in the sheet. You have to draw it bigger on your notes, and I'll give you time to do that. Now, let us move ahead and see what is there in the diagram. What we got to do is to apply this formula. Do we remember this formula? This is the formula for refraction by a curved surface. We will apply this formula twice. First for the first surface and then for the second surface. Do we understand this?
Yes, sir.
Image formed by the first surface acts as object for the second surface. Do we understand this?
Yes, sir.
This is the formula applied for the first surface. You will have to write this formula. This is the formula applied for the first surface. This is the formula applied for the second surface. Just write these two formulae. For the first surface, mu2 is mu L and mu1 is mu M. But for the second surface, mu2 is mu M and mu1 is mu L. Do we understand this?
Yes, sir.
Please write these two formulas and I will be back after a minute. Okay, then we move ahead. And what we do now, we add the two equations. This is how this lens maker's formula is derived. You must remember so that you don't forget it. If I add the two equations, I will get to this equation which is in the red block. Mu m multiplied by 1 by v minus 1 by u will be equal to mu l minus mu m multiplied by 1 by r1, where r1 is the radius of curvature of the first surface, r2 is the radius of curvature of the second surface. This is the formula that you will get. You will have to remember this formula. Now, if I divide it by mu m on both sides, this is the formula that I get. So you have to remember all the versions of this formula. It is good for you. So you have to remember this next version of this formula. And the version that you might have seen in the books is the version here, 1 by v minus 1 by u is mu minus 1 by l. Where what is this mu? This mu l is mu l divided by mu m, or I can say refractive index of lens with respect to the medium. So remember here, mu is the refractive index of lens divided by refractive index of the medium, which is nothing but the refractive index of the lens with respect to the medium. Do we understand this? 1, 2, and 3 different variations of the same formula. Do we understand this? This is the first variation of the lens maker formula. This is the second variation of the lens maker formula. And this is the third variation of the lens maker formula. Do we understand this? Yes or no?
Yes, sir.
I'll give you 2 minutes to write these three variations and then we will move on to the next step. Write these three variations of the lens maker formula. So you have done the three variations of the lens maker formula, and now look at what I am going to show you very carefully. If the object is at infinity, where is the image formed? If the object is at infinity, whether it's a convex lens or a concave lens, where is the image formed?
At focus.
Which focus? Which focus? Which focus the image is formed? There are two foci of a lens. Which focus is the image formed? We don't know this?
Second focus.
Second focus, the image is formed at the second focus, which is F2, second focus. U is minus infinity, and V is plus F2. Do we understand this? Where F2 stands for the second focal length. Do we understand this?
Yes, sir.
So if I put the values here, 1 by V minus 1 by U, we put U as infinity and V as plus F2. This is the formula I will get. 1 by F2 is equal to mu minus 1 into 1 by R1 minus 1 by R2. Do we understand this?
Yes, sir.
This is the most important formula in this topic, because most of the question that is going to come in your exam are going to be based on this formula, and that is why I've taken so much of time and pleasure and pain in making you understand this formula. 1 by F2 is mu minus 1 into 1 by R1 minus 1 by R2, where what is mu? Mu, as you remember, is mu L divided by mu M, diffractive index of the lens with respect to the medium. Now if I put this entire thing as 1 by F, 1 by V minus 1 by U is equal to 1 by F2, instead of calling it F2, I will simply call it as F. Remember, whenever I am talking about the focal length of a lens, which focal length am I talking about?
Second focal length.
I am talking about the second focal length. This is the formula for the second focal length of the lens, not the first one. Remember, the second focal length of a convex lens is positive. The second focal length of a concave lens is negative. Will you remember this?
Yes, sir.
This formula that we have seen is known as the lens formula. The upper wala formula is known as the lens maker's formula. Most of the questions are based on these two formulas. So beta, please note them down. I'll give you time to do it. Then let us move ahead, and I'll just be writing this, uh, comparing a mirror and the lens, whatever formula you have seen. The first formula that we had seen is 1 by V minus 1 by U is equal, plus 1 by U is equal to 1 by F. This was known as the mirror formula. Do we remember this?
Yes, sir.
We have a lens formula here. 1 by V minus 1 by U is equal to 1 by F2 or F. This is known as the lens formula. Remember, the F that we are using here is the second focal length. Yes or no? No or yes?
Yes, sir.
The second formula that we had seen was the magnification. Magnification was minus V by U, and that was nothing but height of the image divided by height of the object. Yes or no?
Yes, sir.
The formula for magnification here, M, is V by minus sign is gone. That is equal to height of the image divided by height of the object. Do we understand this?
Yes, sir.
The formula for power of a mirror was minus 1 by F, and F was in meters. Yes or no? It was positive for concave, and concave was known as convergent mirror. Yes or no? No or yes? Please raise your hands and let me know that we understand this.
Yes, sir.
At the same time, this was negative for a convex mirror, and the convex mirror was known as a divergent mirror. Now, can you tell me what will be the formula of power for a lens? Think, think. What will be the formula for a lens? Remember, For a convergent lens or a convergent mirror, the power is positive. For a divergent lens or a divergent mirror, the power is negative. Can now you apply some common sense and tell me the formula for power of a lens? I will give you. Most of you are wearing lenses, so you must be knowing the power of a lens. I'll give you a minute to think about it and tell me the answer. Meanwhile, you can note down what I have written on the sheet. 1 minute to think and tell me the formula of power. Remember, the SI unit of power is diopters. You would be wearing lenses. You must be knowing diopters. You just have to tell me what is the power of the lens that you're wearing. Remember, you're not wearing a mirror. You are wearing a lens. You have a minute to win it. Then I must congratulate you that you have given the right answer. The power of a lens is 1 by f, which is not minus 1 by f. And remember, this power is positive in this case for a convex lens. Remember, I told you convex lens is same as concave mirror. Both are convergent. See, everything now boils down to, if we understand one thing, we should be able to understand the rest of the stuff. Do we understand this? Power of a convex lens will be positive and the formula is 1 by f. Remember, which focal length are we using here?
Second focal length.
Using the second focal length of a convex lens. That is of prime importance because the second focal length comes in the lens maker formula, comes in the lens formula. That is why we are always using the second focal length and not the first focal length.
Sir,
Do
when do
we?
you use first focal length?
We never use first focal length. No one asked you the first focal length of the lens. Someone asks you, you can obviously find out how much is the first focal length. We will do a question on finding out the first left focal length. Don't worry about that. Don't worry
Okay,
about
sir.
it. You can find out the first focal length on your own itself. How will you find it out? I'll let you know. But first, let us move ahead and what? We had seen some shortcut formulae for the mirror. Now it's my humble duty to let you know the shortcut formulae for lens, because not every time they would be asking you the value of V given the value of U and F. They can give you the value of V and F and ask you the value of U. They can give you the value of V and U and ask you the value of F. So these are the different variations in which these formulas can be asked. And if you can remember them, it is very nice so that you can save some time, which is of prime importance in the examination hall. The first formula is, as you can see, V in terms of U and F. Remember, whenever we are using any formula in this chapter, we have to use it with proper sign convention. Do we know the sign convention of a lens? Yes or no?
Yes, sir.
All objects, all distances are measured from the optical center O in the direction of light. It is positive. Opposite to the direction of light, it is negative. Above principal axis, positive. Below principal axis, negative. Focal length that we use in these formulas is the second focal length. Second focal length of convex lens is positive. Second focal length of concave lens is negative. That is what you use in all these formulae. U for real object is always negative. So V is UF upon F plus U. Do we understand this?
Yes, sir.
Therefore, V by U becomes F upon F plus U, and the magnification of the lens becomes F upon F plus U with proper signs. 1 by U is 1 by V minus 1 by F. This is another way of writing the same formula. So you can find the value of 1 by U. 1 by U is 1 by V minus 1 by F. You take the numerator, you take the denominator, you will get this formula for U. V into F upon F minus V put the values of V and F with proper signs, you will get the value of U with proper signs. Am I getting anywhere? Are we all together in this, or I am going alone?
Yes, sir. Together.
Together. Again, U by V can be written as F upon F minus V. So magnification becomes F minus V upon V. So these are the different ways in which you can write magnification. Remember, these are not different formulae. The only formula that you must remember is 1 by V minus 1 by U is 1 by F, and magnification is V by U. All the other formulas are derived from each other. The more the number of cases that you can remember, the better it would be for you. The faster you would be able to find out the answer in case of a question that comes in the examination hall. I'll give you 2 minutes to note down. Remember, do not mark them in the sheet because it will be of no use. You will not be able to remember it. Read, write. When you are writing, you're also reading. You're also looking at it. All your three senses, your writing, your reading, your brain, they're all working together. That is what we need for this one. Note it down in your notebooks. We will solve one problem based on what we have learned today to wrap up today's class, and the problem comes right now on your screens. A simple problem: the radii of curvature of a double convex lens is 15 and 30. Its refractive index is 1.5. What is the focal length? Tan, tan, tan. I'll give you a minute to find it out. Even without solving anything, you can tell me what two options are not correct. What two options are not correct? Two options are not possible here. What are the two options that are not possible? What are the two options that are not possible? I hope you can see the question on your sheet. Question number 4 from your sheet. Which two options are not possible?
Sir, B and D not possible.
B and D are not possible. Why they are not possible? Why they are not possible?
Radius of curvature of convex lens is always positive.
Talking about the focal length of the lens, beta. Why you are telling me the radius of curvature? Focal length of a convex lens, whenever we are talking about any lens, which focal length are we talking about? Which focal length are we talking about when we are talking about any lens? Which focal length are we talking about?
Convex.
We are talking about the second focal length. We are talking about the second focal length. Will you remember this? I've said that
Yes,
at
sir.
least 50 times and still you can't remember it. Probably there is something wrong with what I'm saying. Is something wrong with my speaker that my voice is not getting on the other end, or something is wrong with the speaker at your end that my voice is not going through. Is my voice going through?
Yes, sir.
Do we remember that we are talking about the second focal length whenever we are talking about focal length?
Yes, sir.
The second focal length of a convex lens, we have talked about it. Is it positive or is it negative? The second focal length of a convex lens, is it positive or is it negative?
Positive.
Therefore, option number B and D are not possible because they were negative. Second focal length of a convex lens is not going to be negative. It has to be positive. Therefore, the correct options are only A and C. Which of A and C? I will leave that to you because the time for this class is over. Think about it. How do you solve it? If you can solve it, it is very good. If you can't solve it, don't worry. How to solve it? Well, you'll have to use your brains. You can also use your sheet because the entire process of solving this is given in your sheet itself, and I'm going to show you a part of that sheet, some special cases, and here, as you can see, is how you solve it. We will be discussing it in the next class, but what I will hope that you will go through these special cases, case number 1, case number 2, case number 3, and so on. I would request you to go through these cases. These are not cases, these are potential questions that are going to come in your examination hall. So I hope that you will go through these cases so that in the next class we can move further ahead. That is the end of this class for today. What we have discussed in today's class, we have seen refraction by a lens. We have seen the lens maker's formula. We have seen that whenever we talk about the focal length of a lens, we are talking about the second focal length. For a convex lens, it is positive. Second focal length is positive. Power of that lens is also positive. The formula is 1 by f. It is a convergent lens. The power is positive. We have seen where the image is formed at different positions of the object. We have seen the lens maker formula 1 by f2. Remember, in the lens maker's formula, we have the second focal length. 1 by f2 is mu minus 1 into 1 by r1. R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the second surface. I have given you a question using lens maker's formula. You have to solve it entire, whatever I have seen. 80 to 90% of the questions in this chapter are from this lens maker's formula. You can understand this lens maker formula, you would have done exceptionally well. On that note, I'll see you tomorrow in the next class. I hope to find you there. Take care and have a nice day. Remember to see those special cases because the way the questions are going to be solved is by listening to this, is by reading those special cases, and you can attempt those questions based on these cases. Take care. Have a nice day. Bye bye.